Hello and welcome to Statistics this spring 2025. I'm Gary Parker. I just want to go over a couple of things with you online and talk a little about statistics. So we're going to cover two main areas of statistics this quarter. We're going to start off with descriptive statistics. And descriptive statistics are calculations that we make, often called summary statistics. Those are things like counting how many items or individuals we have, averaging values, looking for proportions of one group or another. And there's many more we're going to take a look at over the next few weeks, and then charts and graphs. And all of these are used to describe sets of information. And then once we get the descriptive statistics down, we're going to move over to what's called inferential statistics. And that's where we try to make predictions and answer questions. And we're scratching the surface in this course on what statistics is and what we can do with it, but it's going to be a pretty big scratch. We're going to get a lot of stuff done here. So course website, I know most of you already checked it out. General information on the top, syllabus, you should definitely check that out and take the syllabus quiz. Tutoring hours and links, just a subset of some of the stuff that's on the syllabus. Useful websites is an important one. Here I have a link to data sets from the textbook that I put in my Google Drive. They're slightly easier to access, especially if you're a Google user, like Google Sheets, for example. The actual textbook data set. So our textbook comes with a website, and that website has a shitload of data. And if I don't already have it in my drive, or I'm at a computer that I'm not usually at, I can grab usually the CSV version of it. All spreadsheets can view that, and it's a quicker download than, say, an Excel file. But usually is one of these two versions of any particular data set that you're working with. One thing about those data sets, so let's just pick on one. I'm going to go over to my drive to grab it. Let's grab all countries, for example. So here's a data set. Each row is a case, and a case in this case is a particular country, like Chad or Nigeria. And then each column represents a variable because things like population varies from country to country. There are always brief descriptions at the top, and it's not always clear what those mean. You might look at that and say, oh yeah, population, I get it. Okay, so the population of Chad was 15.478. 15.478 what? People? Okay, I'm missing something there. There are always going to be brief descriptions, and it's not going to be obvious what they are. What does rural mean? What does GDP mean? What does density mean? Land area seems pretty obvious, but how did they measure it? 72 what? So you're always going to have to find a description of the sample and the variables. So if I go back to the Lock 5 page here, I can scroll down. I didn't see it at the top. Pretty sure it's at the bottom. Documentation for all data sets. And here, then I can go to one of these, scroll down to page 5, and I can say this is a description, data on all countries in the world. It'd be nice to have a year that this was collected. Maybe that's down below. There we go, 2018. So there's more details down there. And then they tell me things like the land area is the size in 1,000 square kilometers. So that 72 I looked at over here is really 72,000 square kilometers. Population of 7.65 is really, where'd it go over here? In millions. So that's really back there, 7.65 million, so 7,650,000 people. So I always want to get more details about that. Sometimes the details they share might not be enough, and you might need to do some more research. So, for example, the rural one, percentage of the population living in rural areas. Seems pretty straightforward at first, but how do we determine what is a rural area and what is not? So that doesn't seem to be here, so we need to do some more research, maybe, if that variable was important to us for some reason. So language is complicated. And sometimes we take things for granted. So anytime we look up data, we need to have a description of what the data set is. And then we have to have a description of what each variable means. Without that, it's useless. Now, in this case, the cases, the rows were countries, but it's not always that way. There could be lots of different things. Sometimes the cases are people, sometimes they're things. I have another data set over here I'll talk more about in a minute. Each row here is a cricket, and what was recorded is the temperature in the environment the cricket was in and how many chirps per minute that cricket made. Back to the course here. I tend to use Google for spreadsheet work. It's easier to use than Excel. Most of my tutorials on using a spreadsheet are going to use Google Sheets. We're going to write a lot about quantitative information, and the writing principle, make sure you read that, basically says when you answer a question in writing, you should make sure I don't have to look at the question that was asked to figure out what the heck you're talking about. I should be able to look at your answer and understand your point without having to go find the question that you were asked. Make sure you do your autobiography soon. I know a bunch of you already have. Every week has a similar setup. There'll be goals, there'll be videos, there'll be practice, there'll be a reading quiz, and there'll be an application. Sometimes I might have a few other things that I include. Like this week, I collected some data from you. Hopefully you did the data collection survey. Note on that, it is an anonymous survey when you take it. So I don't know that you took it. That's why you're going to have to submit answers from a couple of questions just to let me know you took it. Appreciate that. And good idea to check out the goals. This just gives you a quick outline of what you're going to read about and which sections of the book you're responsible to read for that week. And I highly recommend taking notes from the book. And they don't have to be super detailed, just main ideas. So please do that regularly. Homework problems or the practice problems can be done repeatedly. Remember, these dates here are deadline dates. They're not the date to start it, they're the date to get it done. Should always start things before they are due. Again, you can redo the practice problems as many times as you want before the due date to get a good grade, hopefully 100%. Reading quizzes, you get one shot at those, so answer carefully, take your time, read the book first. Don't try to take the quiz while reading the book. The application problem is something that you're going to write up or type up, and it will often involve a spreadsheet, and I'll always have related videos that relate to something very similar to the application. And other weeks are going to be the same. Goals, videos, reading quiz, practice, application. These aren't visible to you at the moment because I got to do a few updates before I publish them, but they'll all be available very soon. All right, that's it for the intro to the course. I want to go back and just make a couple notes about statistics. So we're going to start off for a few weeks, 3 or 4 weeks on descriptive statistics. The rest of the course, we're going to try and do predictions and answer questions based on data that we've collected. Data is just information. Information comes in the way of variables. Right? The things we collect information on, they vary for each individual. Even if you were making something like hammers, each hammer seems to be the same, but they're not quite the same. They're all a little bit different. So again, we're collecting data. Data is just information. When we collect these data, it's also often going to be placed in a data table. And that data table is going to be made up of rows and columns. The rows in the table are cases or individuals. It could be individual people, individual hammers, individual countries. And then we have our columns in the table. And the columns are variables. And those variables, the information we're going to have are either going to be, the most part, there's other kinds of information, but the stuff we're focusing on, going to be quantitative, or qualitative. And the quantitative is numerical, and the qualitative is categorical. It's another way to think about it. And most of the time, it's pretty easy to tell the difference between numerical and categorical data. Every once in a while, it's a little bit of fuzziness, and you check that out later. Now, the variables are in some way related because they're different pieces of information about each individual, each case that we played with. And sometimes there's interesting relationships between the variables that we collect. So there will be times when we'll compare multiple variables. And sometimes when we do that, we have what are called explanatory and response variables. And if you take any data set and you randomly pick two variables to try and get some kind of explanatory response thing going on, probably ain't going to happen. This is a special kind of relationship between variables. Sometimes, like in a math class, an algebra class, we might have called them like the input versus the output. Or you may have heard terms like independent variable versus dependent variable. So a good example from the book that I like with respect to this idea of like explanatory and response is the cricket example here. I'm going to blow this up a little for you. So here I have two variables in this data set. I have temperature in degrees Fahrenheit and chirps per minute. The temperature is the temperature in the environment when these crickets were being observed. And so this row is for an individual cricket. So during the time this cricket was being observed, the temperature was about 54.5 degrees Fahrenheit. And during that time, the researcher counted how many chirps per minute the cricket made, and on average, it made about 81 chirps per minute when the temperature was around 54.5 degrees Fahrenheit. For another cricket, the temperature was 59.5 degrees Fahrenheit. They made 97 chirps per minute. And notice I've sorted these by temperature. And what it looks like is as the temperature rises, the chirps per minute rise. Now that's hard to see in a table of numbers, but graphically it's a little easier to see. So here we can see as the temperature increases, so that's my horizontal axis here, the number of chirps per minute seems to increase. And it's not perfectly straight, but it's pretty damn straight. Okay. Side note, there's not a lot of observations here. It would be nice to have more. But this seems to imply that the number of chirps depends on the temperature. Now, I just want to show something related to that. Let's go to stat key next. So another part of the textbook website is this app called stat key that we're going to use a lot. And I'm going to jump over to the two quantitative variables section here. And that cricket data also lives in here. So this is that same data. Now here, notice they have it oriented a little bit different. Here they have the chirps horizontally and the temperature vertically. Now, generally, when we have explanatory and response variables, the explanatory variable goes along the horizontal axis and the response variable goes along the vertical axis. Kind of like X is independent, Y is dependent. So X is typically our explanatory variable, and the idea is it explains something about what happens with the other variable. So in this case, we're kind of implying that the faster a cricket chirps, the temperature increases, which kind of implies the crickets are changing the temperature in their environment. I don't think so. Switching the variables, the little button up there, I put temperature down here. Now they still line up. The line looks a little bit different. Here with temperature down here as my explanatory variable, the chirps or the response. Here I'm saying that as the temperature increases, crickets tend to chirp more. Temperature somehow influences the crickets chirping. If it's colder, they're going to chirp less. If it's warmer, they're going to chirp more. Okay, perhaps. Sometimes the order of them doesn't seem to matter too much. Sometimes it does. In this case, chirps, the crickets are not changing the temperature. The temperature, however, is changing the cricket's behavior. Now, all I have here is a mathematical idea that it seems to be as the temperature increases, the crickets increase. That is the idea of association or correlation. Causation is a different idea. It is a reason why one variable affects another variable. I do not have a causation, but that I see correlation or association here that appears to be linear, that leads me to say, okay, we should probably figure out why the temperature might be causing the crickets to chirp more or less as the temperature changes. My point here is that correlation does not imply causation. Just because you see something that forms a pattern doesn't mean there's a legitimate reason for that pattern. For example, here I have some data collected from a guy I know on the internet, and he found, let's see, cheese consumption in the US. So let's see, the data was pounds of cheese per person per year. So in 2000, on average, in the US, an individual consumed about 32 pounds of cheese in a year. In 2023, an individual consumed about 30.6 pounds per year. Next column, bedsheet tangle. That one was recorded deaths in the country where somebody got tangled up in their bed sheets and suffocated and died. And what this graph shows is that the more cheese that was consumed on average in the US, there were more deaths due to strangulation by someone's bed sheets. Do we really think cheese consumption influences deaths by strangulation in a bed? Or maybe the other way around. Maybe somehow the more people who die due to deaths by strangulation in bed, that somehow motivates people to eat more cheese. I don't think so. So here I have a correlation, I have an association, but causation is ridiculous in this case. Another example. This graph here, or the table, let's start with that. I have years and carbon dioxide in the atmosphere. Source is listed down here, and it's parts per million is what that is. So of a sample of air from a certain place on Earth, I think these happened in an observatory in Hawaii. They measured that in 1960, it was about 316, 317 parts per million carbon dioxide. And then later, if we look over in 2005, 2010, we can see it's more like 380 parts per million. So as years go by, we find that there's more carbon floating around in the atmosphere. And you can see that pretty clearly graphically here, right? So this would be, the 10 would be 10 years after 1960, 10, 20, 30, and so on. Now, again, I have a correlation association. As years go by, there's more carbon dioxide in the atmosphere. Causation, that's a whole nother thing. Where is this carbon coming from? Okay. And that has been debated throughout the years. It's pretty clear that human activity has increased carbon in the atmosphere during the last 100 years or so. So again, correlation, do we see a pattern? Causation, what's causing that pattern to happen? This is ridiculous. This is real. This is real. Again, what is the cause? That's a whole nother subject that has to be studied. We study things like that by doing experiments. Sometimes they're observational studies. Sometimes they're experiments where we change things. More on that later. All right, have a good day. I'll do some more stats with you in the near future.